Now let us talk about isotopes. Isotopes are those atoms of the same element with the same atomic number but a different mass number. Right? In the previous video we were talking about atomic and mass number, right? So mass number is the total number of protons and neutrons, and atomic number is the number of protons or electron present in an atom. So if two atoms exist of same element in which the atomic number, that means the number of electron and number of proton, are same, but due to the difference in number of neutron in two atoms, the mass number of two atoms get changed, right? It becomes different. These atoms are called isotopes, right? And the example of that in which isotopes, the elements in which isotopes exist are hydrogen. Hydrogen has three isotopes: protium, deuterium, and tritium, right? In protium, it is the normal one, ordinary hydrogen, in which the number of electron is equal to number of proton, that is equal to 1. No neutron is present in ordinary hydrogen. But in isotopes of hydrogen, we have one proton, one electron, and one neutron also is present. Right? In tritium, very heavy hydrogen, one electron, one proton, and two neutrons. So 1 plus 2 will give you total 3 mass number. Here in protium the mass number is 1 only. In deuterium the mass number is 2. Tritium is having mass number 3. Right? Similarly, carbon has 3 isotopes with mass number 12, 13, and 14, known as carbon 12, carbon 13, carbon 14, because the atomic number in all the three cases you can see remains 6. But in first case, in ordinary carbon, the mass number is 12, and second one, its isotope, that is mass number is 13, and third one mass number is 14. Three types of atom exist in carbon element. Chlorine has two isotopes, chlorine 35 and chlorine 37. Now the atomic number in both the cases remains same, that is 17, but the mass number is changed, 35 and 37. So the properties of isotopes, the isotopes of an element have same chemical properties. Their chemical properties do not change because their atomic number is same. Due to the same atomic number, all the isotopes of an element have the same electronic configuration. Electronic configuration. Isotopes differ from each other only in their physical properties such as density, melting point, boiling point, etc. due to the difference in their mass number. Right? Density, melting point, and boiling point will get changed. Now, contradiction of Dalton's atomic theory. Right? He has said that all atoms of an element are identical, but in some cases, in some elements, isotopes also exist. So it is a contradiction of Dalton's atomic theory. Now let's see arrangement of electrons around the nucleus of an atom. we were we used the word electronic configuration just now, right? So electronic configuration, as the name itself suggests, that electronic configuration is depending on electrons, the number of electrons present in an atom. Now we have electrons, right? And we know that they are revolving in orbits of an atom around the nucleus. Now, how to arrange those electrons in different orbits. This is called arrangement of electrons around the nucleus. Now, electrons revolve around the nucleus in imaginary path called orbits. The orbit closest to the nucleus is called the first orbit, next orbit is called second orbit, and so on. And they are labeled as, represented as K shell, L shell, M shell, N shell. K is called first shell, L is called second, M is called third, and fourth, and so on. Each of these shell contain different number of electrons depending upon the amount of energy associated with the atom, right? As we have discussed, the shell closest to the nucleus has the lowest amount of energy and hence contains the least number of electrons, right? And we have a rule also through which we can find out in first shell how many number of electrons are present, and in second shell how many number of electrons are present, and so on. So the formula is 2n square, and n denotes the number of shell. Suppose for K shell, n is equals to 1 because it is the first shell, it is closest to the nucleus. So the number of electron will be 2n square. That means 2 into 1 square. 1 square is 1, into 2 will give you 2. So maximum 2 electrons can be accommodated in first shell. L shell, n is equals to 2. Number of electrons 2 into 2 to the power 2, that is 4 into 2, 8. M shell, n is equals to 3. Number of electron 2 into 3 to the power 2, 18. 18 electrons can be accommodated in M shell. N shell, similarly, we will use the formula and we'll get the number of electrons in N shell will be equal to 32. Now, second rule, electrons are not accommodated in the given shell unless the inner shells are filled. You can't do this. That suppose you are sitting in a class, right? First row contains, can accommodate 2 children, second row accommodate 8 children. So if the first row is not filled with 2 children, then you cannot send the third child to the next one, right? If there is a space on the first row, the children has to sit on first row only, right? So once first shell is filled, then we can move to another shell. But if suppose if you are saying that we have two shells and two electrons are there, one you placed in first shell and one you placed in second shell, so that is not correct arrangement. Once the complete shell is filled, then we will move to the next one. This 2n square is known as Bohr-Bury scheme, as it is given by scientists Bohr and Bury. Hydrogen element is given, atomic number is given, electronic configuration is given. Right here we have K, L, M and N shell. First shell can fill 2, L shell can fill 8, M 18, N 32. Right? So we have atomic number 1. Atomic number 1 gives you the number of electrons. Only one electron is there, so it gets filled in K shell. One electron, that's it. Helium 2. Atomic number 2, number of electrons 2, filled in K shell, 2 electrons, because it can accommodate 2 electrons. Now 3. So first 2 electrons get filled in K shell and one more remaining will go to L shell. Lithium, atomic number 3 and number of electrons 3. 2 gets filled in K shell, 1 gets filled in L shell. Beryllium 4, 2 gets filled in K shell, remaining 2 will go to L shell. Now boron 5, 2 in K shell, remaining 3 in L shell. Now L also can fill up to 8 only. After 8, it will move to M shell, right? Thus, the maximum number of electrons in the first orbit is 2, and the second is 8, and third is 18, and in fourth, 32. However, the outermost orbit, we have one more rule, that the outermost orbit of an electrically neutral atom cannot have more than 8 electrons. Okay, so when we come to M shell, right, although it can fill maximum of 18 electrons, but if it is the last shell, then we will only fill 8 electrons in it, and the rest of the electrons will move into another shell. This we will see with the help of an example. Now this rule is called octet rule. Octet rule says last shell of any atom contains not more than 8 electrons. If more than 8 electrons are there, we will keep 8 electrons in that shell and the remaining number of electrons to the another shell, right? And if an atom is containing only one shell, that is K shell, then it will follow duplet rule. That means it will be having only 2 electrons, right? In case of helium, atom has 2 electron. They occupy the first and the only shell of the atom. First shell is only the shell, then octet rule is not followed, then duplet rule is followed. A lithium atom has 3 electrons, two of which occupy the first shell and third will go to the another shell, because in K shell only 2 can be there. A neon atom has 10 electrons. So the first shell takes up 2, remaining 8 will come to the next one. A potassium atom has 19 electrons. So 2 electrons will go to the first shell. How many remaining? 17. 8 will go to the second shell. How many remaining? 9. Now third shell can accommodate 19, but 18 electrons, but it is the last shell, and last shell according to octet rule should not contain more than 8 electrons. So total we have 9 electrons. We will keep 8 electrons in the L shell and place remaining 1 electron in the next shell, that is N shell, right? First shell 2, remaining 17, next shell 8, remaining 9. So we cannot fill that those total 9 in M shell because of octet rule. 8 in M shell, 1 remaining in next shell. Taking help from the above example, write the electronic configuration of the following elements. Right? You will find it interesting to do.